Okay, so as in the last video, we have discussed about electronic configuration, and we discussed about that initially electron will be going in which subshell of the shell. Alright, we made our trick. Alright, we know that in first shell we have only S subshell, so we wrote one S, and we know that S will gonna hold two electrons, so we wrote 2 on the S. Alright, then we were known in second shell we have S as well as P subshells, so we wrote 2S because S is the subshell of 2 second shell, and 2P because P is the subshell of second shell. That's why we wrote 2S and 2P, and S holds 2 electrons and P holds 6 electrons. Alright, then we moved towards third one, which we were known about that third shell will gonna have SPD, which means third shell will gonna have 3 subshells in it. Alright, so 3S, 3P, 3D. S holds 2 electrons, P holds 6 electrons, and D holds 10 electrons. Alright, these all are the subshells of third shell. That's why we have written 3 in front of them, in the left hand side of them. Alright, then shell number 4 holds SPDF. That's why we wrote 4S, 4P, 4D, 4F, and S holds 2 electron, P holds 6 electron, D holds 10 electron, F holds 14 electron. Then we made a trick. We said we'll be coming from up to the down. Alright, so 1S, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, and then so on. Alright, then we made this general form of filling the electrons in the subshells of the shells. Now we are going to study the electronic configuration of initial 10 elements of the periodic table. Then we're gonna study further elements, or we're gonna study the electronic configuration of the further elements, because we are gonna discuss till 30th element, since there are not there are however there is only one exception. So there is an exception in chromium atom, which has atomic number of 24, and I guess copper, and that is on 29. But we're gonna look into it when we'll be discussing the electronic configuration of those atoms. In this video, we are going to discuss the electronic configuration of initial elements, of initial 10 elements of the periodic table, which includes hydrogen, helium, lithium, beryllium, boron, carbon, neon, nitrogen, oxygen, fluorine, and neon. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Alright, so we know that this, the one which is written on the upper side, represents what? It is the atomic number. Atomic number. Alright. And downside is written the average atomic mass. Not atomic mass, however, average atomic mass. Alright. So we know that atomic number, which is denoted with Z, is equal to is equal to the electrons number. Alright, which means the electronic or the atomic number it has will be equal to the electrons in it. Alright, which shows us that hydrogen has only one electron. Since it has atomic number 1, so it will gonna have one electron in it. Alright, so initially let me write this general form down here. Alright, what it is, let's see. Initially we have 1s2, so let's start writing from here. 1s2, then we have 2s2. Alright, then we have 2p6, then we have 3s2, 3p6, alright, 4s2, 2s2, 3d10, 3d10, and then we have 4p6, and so on. Alright, if we will be needing more, we will gonna write or we're gonna drive with this. Alright, so we have written our general form here, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Initially we need to fill this 1s2. Alright, we know that hydrogen has only one electron, so its electronic configuration would be, I'm writing with white, then I'm gonna highlight it. Alright, 1 s will gonna hold 2 electron, but hydrogen has only 1 electron, so it will gonna hold only 1 electron. So 1s1 is the electronic configuration of hydrogen. Alright, 1s1 is the electronic configuration of hydrogen. Now we are going towards the helium, and we know that helium has 2 electrons, right? So we know that initially we need to fill 1s2, and s holds 2 electron and helium has 2 electrons, so of course here it will gonna hold 2 electrons. So the electronic configuration of helium is 1s2, the electronic configuration of hydrogen is 1s1, helium's electronic configuration is 1s2. Now we are going towards lithium, and lithium has 3 electrons. Alright, so we know that initially 1s2 would be filling, and it has already holded 2 electrons, right? Now 1 electron is remaining, since we know that 3 electrons are there in the lithium element. So 2 electrons have been filled by s. Now we need to take this 2s2 wala. Alright, so 2s, but we know that only 1 electron is left, since s has already hold 2 electrons. Now 1 electron will be held by this. So 1s2, 2s1 is the electronic configuration of lithium. 1s2, 2s1 is the electronic configuration of lithium. Now we are moving towards beryllium, and beryllium has atomic number, which means it has electrons 4. Alright, so initially 1s2. So initially 1s2. Alright, then we know that we have 2s2. So 2s2. So 2 plus 2, 4 electrons, and we know that beryllium has already 4 electrons. Alright, so 1s2, 2s2 is the electronic configuration of beryllium. Again repeating, 1s1 is the electronic configuration of hydrogen, 1s2 is the electronic configuration of helium, 1s2, 2s1 is the electronic configuration of lithium, then 1s2, 2s2 is the electronic configuration of the beryllium. Now we are going towards boron. So 1s2, then we have 2s2. Now 4 electrons have been filled. Now we need to start 2p6. Alright, and we know that p can hold 6 electron. However, only 1 electron is left, since we know that boron has only 5 electrons, and 4 electrons have been filled by the s subshell of the first shell and s subshell of the second shell. Now there would be only 1 electron. Alright, 1s2, 2s2, 2p1. 2 plus 2, 4, 4 plus 1, 5, and 5 is the atomic number of boron, which means this is right. So electronic configuration of boron is 1s2, 2s2, 2p1. Now we are moving towards carbon, and carbon's electronic configuration, since it has 6 electrons. Alright, boron was having 5 electrons. Okay, so initially 1s2, then we know that 2s2, then we know that we need to start with 2p. Alright, so 2, 2 for, and now we know that carbon has 6 electrons, which means 2 electrons are left, so p will gonna hold 2 electrons. So now 1s2, 2s2, 2p2 is the electronic configuration of, you know what, carbon. Alright, carbon. Okay, so now we have nitrogen. Wait for it. Okay, so now we have nitrogen, and nitrogen has atomic number 7. Alright, which means we're gonna 1s2, 2s2. Now we need to start 2p. Alright, so 2, 2 for, Now 3 electrons are remaining and p will gonna hold 3 electrons. Alright, so 1s2, 2s2, 2p3 is the electronic configuration of nitrogen. Alright, again repeating for you guys, 1s1 is the electronic configuration of hydrogen, 1s2 is the electronic configuration of helium, then 1s2, 2s1 is the electronic configuration of lithium, then 1s2, 2s2 is the electronic configuration of beryllium, 1s2, 2s2, 2p1 is the electronic configuration of boron, then 1s2, 2s2, 2p2 is the electronic configuration of carbon, then 1s2, 2s2, 2p3 is the electronic configuration of nitrogen. Now we are moving towards oxygen, which has 8 electrons. So initially 1s2, 2s2. Now we need to start with 2p. Now 2 plus 2 is 4 and oxygen has 8 electrons. So 8 minus 4, 4, which means 4 are left still. So p will gonna hold 4 because it has capacity to hold till 6 electrons. So it has holded now 4 electrons. So 1s2, 2s2, 2p4 is the electronic configuration of oxygen. Now we are moving towards fluorine and it has 9 electrons. So 1s2, 2s2. Now we need to start with 2p and 2 plus 2 4 and fluorine has 9 electrons, which means 5 are left. So 5 will gonna help p. Alright. So 1s2, 2s2, 2p5 is the electronic configuration of fluorine. Now last but not the least, electronic configuration of neon, which has 10 electrons. So 1s2, 2s2, 2 plus 2 is 4, which means 6 are left. So 2p6. Alright, and this is the electronic configuration of neon, 1s2, 2s2, 2p6. So this was all for today. We have discussed the electronic configuration of initial 10 elements of the periodic table. In the next video, we're gonna look more into electronic configuration of the elements in the periodic table. Alright, so this was all for today.